Hello everyone. Today we will see the Leetcode problem number 1458, max dot product of two subsequences. So let's see what the question says. Given two arrays num1 and num2, return the maximum dot product between non-empty subsequences of nums1 and nums2 with the same length. Okay. So we have to choose any of the subsequences from num1 and num2, and we have to take the same length. The subsequences should be of the same length from both the both the vectors. After that we have to take the dot product of them. Okay, the dot product means the multiplication of the adjacent elements and addition of them, addition of their multiplication. Okay, so now let's see what here the maximum answer we will get when we choose 2 from this 2 and minus 2 subsequence from num1, and this 3 and minus 6 from num2. So we will get this 18 as a maximum. Okay, so for this the constraints we have to see that like 500. So the maximum possibility, the time complexity will be possible, will be the 500 into 500, and then so the n square possible. Okay, and after that if we try to figure out the n to the power 4, so it will take 5 into 10 to the power just like 8, so it cannot be possible. Okay, so 5 into 10 to the power 8, because only if it was 1 so it can be possible, but now it is a 5 here, because 5 because it will be like 500 into 500 into 500 into 500 into 500. So this 1 2 3 4 5 6 7 8. Okay, so into 5 into 10 to the power 8 will be there, so it cannot be possible. So we will have to figure out any of the optimized approach. So we can simply see like pick not pick option. Okay, so I will show you the approach of tabulation approach. I will show you. So just take this example, this. Okay, I will copy it just like. Okay, then now this example, just we will see it as a dp 2 1 minus 2 and 5. Okay, then okay, 1 2 3, here is a 3 0 and minus 6. Now when we have to take 3 and 2, so we have 6 here. Okay, 3 into 2 we have 6. We have to maximize it. So if we are taking 2 and 0, so we have 0 here. Okay, when we are taking 2 and 6 minus 6, so we have minus 12. Okay, minus 12 here. Okay, then when we have to take 1 and 3, so we have 3 maximize, and then if we are taking 1 and 0 now. Okay, now let's focus here that when you are taking 1 and 0, so now it will contain 0, but now in previously you can also take 2 and 3 and 1 and 2 with combined order. Okay, means like you can pick up the 2 3 and you can pick 3 and 0 and 2 and 1. So this from n1, from vector 1, this from vector 2, so it's contains 6 and it will contain 0, so their addition will be 6. Okay, So this can be possible. Again, now, so now you can take this only or with this also. So for this you have to figure out the maximum from this area, maximum from this area. Okay, for this, so the maximum from this area will contain 6 plus 0, means we have here 6 now. Okay, we have now here 6. Okay, after this, okay, after this, now we will take for 1 and minus 6. Okay, 1 and minus 6. Okay, so 1 and minus 6 will be the minus 6. Okay, but now when we are taking 1 and minus 6, okay, just 1 and minus 6, when we are taking it, when we are taking 1 and minus 6, so we can also take 2 and 0 or 2 and 3. Okay, so with 2 and so the possibilities I will show you here, that when we can take 2 into 3 and 1 into minus 6. Okay, or the possibility can be the 2 into 0 and 1 into minus 6. So this can be possibilities. Okay, so for this we have to get the maximum from this area, maximum from this area. Okay, so how we will get the maximum from this area? So while traversing in the direction of row, so we have to maximize it with the previous. Okay, we have to take the max from dp of current I or j and dp of current I and j and dp of I and j minus of 1. Okay, so you have to take this. Also, if we talk about this, if we talk about this area, okay, if we talk about this area, this, okay, so this area will be required for this to figure out this answer. Okay, this whole area will be required to get this answer, and to get this answer we doesn't require any area. Okay, because when we have 5 and 3 in the pair, so we cannot get any of the number from this num2. Okay, so now what's our approach will be, this is all over the approach. Now let's see the code. Okay, so we have taken the 2D DP, here. Then we have initialized it with the int minimum, because it can contains the negatives also. Okay, so we can at any time, if we initialize it with 0, so we can get minus answers. Okay, also, so we can also get the minus 12 like answers. Okay, so that's why we have to take it as an int minimum. Okay, then after that we have applied the double for loop, and it will traverse row wise and column wise. Then we are initializing. Okay, we are storing the product into nums1 of ith and nums2 of jth. Okay, and after that the dp of ij is equal to the product. Okay, after this to get the prefix maximum from the previous maximum. Okay, to get the previous maximum in what we have discussed here, that we need the previous maximum arrays. Okay, previous maximum. Okay, so when we have to figure out this answer, so we have to know the maximum from this area. And when we have to know the maximum, we have to find out the answer for this one, so we have to know the maximum from this area. Okay, and after that, if we want to know the if we want to find out the answer for this area, so we have to know the maximum from this area. Okay, so for this we will we will maximize this position with the previous one, we will maximize this position with the previous one, and after that we will maximize this position with this previous one. So at this position only we can get the maximum one. Okay, so for this it will be come from this one. Okay, the maximum will be stored here at this position. Okay, then okay, if the I and j is present here, if I and j are both are greater than, means like greater than 0, so we can get it from the previous index. Okay, I minus 1 and j minus 1. Otherwise if we try to get this one, so it will be out of bound. Okay, then if so this cannot be applied to the base conditions, like for these areas. Okay, these areas means like, okay, so for these areas it cannot be possible. So for that, if I is equal to 0, I is greater than equal to 0, here the j will be required. Okay, here the j, okay, so because this will be the j, so that's why if j is greater than equal to 0, so we can take it from the previous index. Okay, the maximum from previous cell. Okay, so the same we are doing in our code, that if we have I is greater than 0 or j is greater than 0, so we will take out from the previous maximum. Okay, we will take out the maximum from the previous cell. Okay, and at every time we can get the maximized answer. Okay, and after that our last cell will storing the maximum answer, and this is our solution. Thank you.